We're rolling. Okay, this is a demonstration of the output of a circuit, formerly known as the Bedini SG Energizer, and we got a circuit comprised of a 12-volt battery. We've got the trigger circuit, and we have the coil assembly, which is basically a PC cooling fan that's been modified. Both meters are currently reading about 12.4 volts. Just to illustrate that the fluke is reading the same voltage as the other meter. Okay, attempt to connect this up. Okay, so now the fluke is reading the output of the circuit, and we're going to turn the circuit on by just spinning the coil. You can see the neon light lighting up. Okay, the voltage comes up, fluctuates a little bit around 20, and you can see that we clearly have a difference in our voltage, significant difference in our voltage between the input 12.42 and the output around 15 volts. Not all meters will pick that up. The flukes will pick that up, and we have indication of high voltage here as represented by the neon lamp illuminating. Okay, next we have an oscilloscope over here, and we're going to hook up the probe, and we're going to see if we can see a waveform here. Okay, there we are. So we're showing a waveform, and it's a DC pulse, and it seems to be about 1, 2, 3. We're on the 5-volt range, so 3 times 25, it's about 75 volts. So that's what I suspected, is that we are getting the spike in voltage as described by John Bedini in his formal circuitry. And again, this is simply just a quick and dirty version that we built just to illustrate the principles of the John Bedini circuit. It is in no way, shape, or form anywhere close to the actual larger versions that have been built. But it does illustrate the voltage spikes and clearly indication of longitudinal wave that's being produced. Another interesting point is to watch this generator speed up and slow down. One hand here, trying to do all of this with one hand. And slow the generator down. Okay, and there we are. I got the trigger level set up just to kind of freeze this so you can actually see what's going on with this waveform. Again, just to show here that we are in fact on the 5-volt setting and putting out approximately 75 volts. Not too shabby for a little motor. And the voltage on the meter goes back down to a different level whenever we clip on the scope because I think the scope loads it down. So we're clearly not receiving a high current level on this. And it's understandable. You know, you're not going to be powering a cell phone with this thing by any stretch of the means. But it is kind of interesting to see that type of voltage coming out of a simple 12-volt circuit.